x squared plus y squared equal to 2 to the x plus y. X and y are integers. X plus y is what? So here, left hand side is x squared y squared, and right hand side is 2 to the x. By power rule, if you have plus in the power, it will be product in the base. 2 to the x times 2 to the y. Okay, now let's check some small example here. If x equal to 0, then y squared equal to 2 to the y. And y is integer, so y cannot be negative because then right side is not integer. For example, 2 to the negative 1 is 1 half. So if we check y0 doesn't work, y1 doesn't work, y2 works, and after y3 and so on, right side, y3 doesn't work, y4 also works, so y equal to 2 and 4. And after 4, because let me tell you, like 1 squared, we have 2 to the 1. 2 squared, 2 squared, they are equal. It is smaller. 3 squared, 2 cubed, it is greater. 4 squared, 2 to the 4, it is equal. After here, 5 squared, 2 to the 5. From here, all of them will be greater. Why? Because the next one, for example, is 2 to the 664 is 6 squared. This one will be multiplied by 2. But this one, the difference is not multiplied by 2. And you can prove it easily. For example, m plus 1 squared is less than 2m squared. If you want to prove this, if you expand, it will be m squared will be cancelled. 2m plus 1 is less than m squared, which is m minus 1 squared greater than 2. So because here, as you can see from after m is what? M plus 1 is at least for example 5 or 6. So it is correct. So after here, always 2 to the m is greater. So y24 works here. So if we want to write all answers, let's write x0, y24. Let's write all of them. x0, y2, x0, y4. Now, let's check next case. If x is 1, then y squared plus 1 equal to 2 to the y times 2. Okay. Again here, y is at most negative 1. So if you check negative 1, it will be 1 here, 2 doesn't work. If y is 0, on the left side 1, 2 doesn't work. If y is 1, 2 times 2, 4 doesn't work. If y is 2, it's 5, it's 8, it doesn't work. And after that, like exactly this proof, you can say we don't have any answer. Now let's check x equal to negative 1. Then again, y squared plus 1 equal to 2 to the y minus 1. If you check, for example, y equal to, because here is integer, here is at least 0. So, because it's at least 0, y is at least 1. So if you take 1, it doesn't work, it is 2, it is 1. If y is 2, it is 5, it is 2. If y is 3, it is 4, it's 10. Y is 4, it is 8, it is 17. If y is 5, it is 16, it is 26. Y is 6, 32, 37, 7 will be 2 to the 6, 64, this one. So this one will be greater. So here again, we don't have any answer. Now, we want to check that. Can we consider for general n? So let's consider different cases. If, for example, x, y are greater than or equal to 0, if both of them negative, if both of them negative. Case 1. If x and y are at least zeros, x squared plus y squared equal to 2 to the x times 2 to the y. Okay. And then we say, okay, if x and y are at least 5, then we know x squared is less than 2 to the x. We proved in previous page. Y squared is also less than 2 to the x. So x squared plus y squared is less than 2 to the x plus 2 to the y. What do we know? X squared plus y squared is what? 2 to the x times 2 to the y less than 2 to the x plus 2 to the y. If we take all things to the left hand side, then we can factorize, and 2x minus 1. 2y minus 1 is less than 1 because we have one more. And it's a contradiction if x and y are at least 5. Now let's consider something. So because both of them cannot be 5, so one of them is 1 or 2 or 3 or 4. So you can check, for example, we've checked x equal to 1. And look, when you find, for example, x equal to 0, say 0, 2, 0, 4. And the problem wants what? Wants x plus y, I think. Yes, x plus y. So x plus y here, you can switch x and y, but it has no effect on x plus y. So it is 2, 4. If x equal to 1, then y squared plus, what x equal to 1 we've checked. So let's check x equal to 2. If x equal to 2, then y squared plus 4 equal to 4 times 2 to the y. So if you take y0, because we've checked x0, 1, 2, x0 and 1 here, we start from y2, okay? Because if we have y1 answer, we've checked it in x1. So if y is 2, it's 4 plus 4, 8, 2, 2, 16. It doesn't work. If y is 3, then it will be odd. It doesn't work. If y is 4, 16 plus 4, 20. It doesn't work. Also, we can see it doesn't work. Y is 4 and so on. This part will be greater after some parts. If x equal to 3, then y squared plus 9 equal to 8 times 2 to the y. So here, if we check y 3, 9, 9, 18, so right side will be greater. Okay, obviously. And here, each time it will be multiplied by 2, but it wouldn't be multiplied by 2 like the proof of previous page. If x equal to 4, we can say y squared plus 4 squared, which is 16, equal to 16 times 2 to the y. So here, if we consider y equal to 0, if we check, we have the answer, but we should start with y4. This one will be so much greater than this, because we've checked here, x plus y will be 4. Okay, so we've considered the case that x plus y are at least 0. Now let's check one of them negative and then both of them negative. Let's consider case 2. In case 2, one of them negative, one of them positive. Okay, for example, without loss of generality, x is less than 0, y is greater than equals. And x squared plus y squared equal to 2 to the x plus y. So here, I say because x is negative, I consider x equal to negative w, so w is positive. And then x squared plus w, instead of x, I write w. Negative w will be w squared. So y squared equal to 2 to the y minus w. Now here we should check and we know y and w. Y is at least 0, w is positive. We should see, can we find any answer here? Okay, let's check. Let me tell you a hint for this part. This one is integer, okay? So this one also has to be integer. So we consider, for example, if y minus w equal to 0, if y minus w equal to 1, and because it is integer, it should be at least 0. Y minus w at least 2. So if you check this one, then they are equal, so 2y squared equal to 2 to the 0, which is 1, and it's contradiction. Here it will be y equal to w plus 1, so w squared plus w plus 1 squared equal to 2. Here it is not again possible because one of them odd, one of them even, and if it is at least 2, so if you consider remainder of w squared and y squared when divided by 4, we can prove that each of them is 0 or 1. Okay, you can do it as homework. Prove this, and then it will be 2 to the y minus w, which is multiple of 4, 40. So we conclude that wy should be even. So you divide both w and y by 2, then it will be w squared over 2. So y squared over 2 squared equal to w by minus w. Then you can do what? You divide by 4 both sides, it will be minus 2. And then again, you say the same thing. If it is 0, if the numbers we have, for example, sum of two squares equal to 2 to the something, you say if it is 0 the power, we have it is odd. If it is 1, it will be something like this. And then it should be at least 2. Again, you divide and divide by power of 2, and so on. And the idea is this idea is also useful in IMO. So it was homework number 1. Try to do this way and see can we find any other answer here. Okay. Now let's consider both of them are negative. Okay, let's consider case 3. if both x and y are negative. So x less than 0, y less than 0. So x squared plus y squared equal to 2 to the x plus y. Because both of them are negative, so 2 to the x plus y is 2 to the negative number is not integer, but x squared plus y squared is integer. So we've reached contradiction for this part. Okay, if you had questions, send message to my WhatsApp number and please don't forget to subscribe. Turn on the bell and like the video. Thanks. Bye.